All right, guys. So good evening once again. So we're continuing from where we left off in factorization. We are at quadratic factorization. We would have defined what a quadratic expression is, and we would have been introduced to two different methods based on how the expression appears. We talk about quadratic expression, the general form of it would be ax squared plus bx plus c. That's a general form of a quadratic expression. Now, we can factorize a quadratic expression based on two main features. So we may look at an expression, which is a quadratic expression where you have a coefficient in front, the x squared. And when we say a coefficient, you're referring to the number in front, the x squared. So we have two scenarios for the numbers. So if you don't obviously have a number in front of the x squared, then the number in front of the x squared is going to be 1. Now, other than that, you will either have a number which is greater than 1, which would be a positive number, like for instance, 2, 3, 4, and so on, or you may have a number which is less than 1, which could be either -2, -3, and so on. Now, in the case, which we refer to as case 1, where there's no obvious number in front of the x squared, and we have 1 as the coefficient. In that case, the general rule is that we find two factors of the last term, which is in the general sense c, or the constant. Find two factors of that number in the last term, that when we find the product of those two numbers, we actually get the last term, but when we add them, we get the middle term, the coefficient of the middle term. That is the number in front, the x now. So you remember now we have x squared, we have x, and then we have the number by itself, which is a constant. So the last term, which is the constant, you find two factors of that, two numbers that multiply to give you that number. And then those same two numbers, when you add them, you will get the coefficient of the middle term, which is the number in front of the x. That is when you have the x squared having 1 in front of it. So that's case 1. So we were working on case 1 from last class, and we would have gone through an exercise with some questions. And so we would have got a sense of how to do those. But I'm going to be highlighting some important points about case 1 in terms of the features of the terms. So the general form of case 1 would be x squared plus bx plus c. So in this case, the a then would be 1. Now b and c, we know that those are numbers that we can replace when we're dealing with a specific form. All right, now some things to note here. So when c is positive, and this is a key feature of quadratics, and once you understand the dynamics of these features that we're going to be looking at, it will become a little easier for you to factorize these expressions. So the first thing to note is that when c is positive, when that last term that you find in the product of finding the two factors that give you that last term, when that last term is positive, it's a positive number, it means that both the factors that you're using to multiply that last term are both the factors that multiply to give you that last term. Both of them can either be either two negatives or two positives. So they both can be positive or they can both be negative. Now, I hope you are listening to what I'm saying, because I know it might sound a little weird at first, but what I'm saying is that if you look at a quadratic in this form and the last term is positive, once there's a plus sign in front of the last term, it means that the two numbers that you're looking for, the products of the two numbers that you would multiply to get this last term, either can be both positives or both negative. That means the two products, both of them either going to be positive or both going to be negative. Raise your hand if you understand clearly what I'm saying. Anybody understand what I'm saying?
Sir,
Please repeat.
All right. Was it that you didn't hear me, Miss Williams, or is it that you...
Sir, I heard, but I don't comprehend.
All right. So remember in the previous exercise. All right. So maybe by way of an example, you will understand what I'm saying. All right. So let me just write a specific form of this expression. Let's say you have an expression x squared plus 5x plus 6. All right. What is it that you can say about the last term here? What is the sign of the last term? The last term here would be
positive.
It is positive. So when you're factorizing this, what you generally have to do? What is the rule, Ms. Williams? When you have to factorize this, what you do?
It will remain positive, sir.
I'm not sure what you're saying. Remember, I gave you some steps as how to factorize this. What is the first step?
So, sir, you group the like terms.
That's not the first step, Ms. Williams. Can anybody else tell us what the first step in factorizing this? Is there
Sir, you find two number that when they multiply, give you the last number, and when you add it, gives you the middle.
Correct. So in this case, which two number we could multiply to get this last number? What is the last number here?
Sir, could
6,
you...
sir.
What is the last number here?
6.
6.
Right. Which two numbers you can multiply to get 6?
2 and 3.
All right. Now the general rule, you're finding two numbers that you can multiply to get 6. The same two numbers, when you add them, you should get this 5. Anybody recall that? Except for Miss Trivia? Everybody remember that? You're searching for two numbers that you multiply to get the last term, but when you add them, you get the coefficient of the middle term. All right. Can you just walk me through, Ms. Trivia, walk me through the factorization process of this expression? Tell me how to factorize it.
Okay, sir. So you would have 2 and 3 as the two numbers.
All right, so the two numbers that we are using to factorize would be 2. So we notice that 3 times 2 would be equal to what? 3 times 2 equal to what?
6, sir, 6.
All right, so 3 times 2 equal to 6, or we could say 2 times 3 equal to 6. Now, when we find two numbers that multiply to give you 6, what is the next thing that we need to do?
Are you going to 3 plus 2 would equal to 5.
All right. So what we are doing, we are checking to see if these two numbers, when we add them, we will get 5. Oh, in this case, you see clearly that 3 plus 2 give you what? 5.
5.
Right. Now, if you are to continue to factorize this, what would you do?
Okay, sir. So you're going to have x squared. You're going to plug them into the equation.
All right. So we're going to replace the 5x with the two numbers as a sum, but we're going to put x beside them. So we're going to have bx plus 2x. Right, we're going to sum these two, but we are putting x beside them, because what we're doing, we are going to take out this 5x and replace it with 3x plus 2x. And remember now, the order in which you have these numbers, the 3 and the 2, doesn't really matter. You could have the 2x first, then the 3x after. It would make a difference. All right, so taking out the 5x, replacing that with all of this, because obviously when we add these two, we still get the same 5x. So we will now have x squared plus 3x plus 2x
Plus 6.
All right, so plus 2x plus 6. All right. All right, so everybody's with me so far. What is the next step, Ms. Trivia?
So you're going to find the common terms
All
between
right.
the first two.
Right, so now, as Ms. Williams would have alluded to, this is the point now when we are factorizing by grouping, because we have 4 terms now, so we group the first 2 and find the common factor, then group the second 2 and find the common factor, and factorize each pair by the common factor. So what is the common factor in the first pair? What is common to both terms here?
X, sir.
X. So we would pull out our X as our HCF. Then we open our bracket. We say X into X squared, leave the, so X cancel out with one of the X, leave X here in the bracket. Everybody with me so far? All right, so when we now say X into 3X, the X will cancel out and leave 3. And so we will get X bracket, X plus 3 in the bracket. All right. Now, what would be common for the next pair? What would be the common factor for 2x and 6? Ms. Trevor, are you working along with me here? Anybody else can continue because Ms. Trevor is not with us, it seems. Michelle?
Sir, 2.
All right, so the common factor here will be 2. And we say 2 into 2x. The 2 cancel out, leaving the x. Keep the plus sign. 2 into 6 now give you 3. So we put 3 in the bracket and we close the bracket. Now, we notice that the 2 expressions here in the brackets are exactly the same. So that's what we really want. So from there now, we can treat these expressions as the HCF. So we pull out x plus 3 as our HCF because it is common to both expressions. And so now we're going to factorize by this. So we have it as our HCF. So we open our next bracket. And then now we would now divide each of these terms with the x squared plus 3. So x times x times x plus 3 divided by x plus 3. You see that the expression in the bracket would cancel out, leaving this x outside here. So we would just put that x in this bracket. All right, so we now keep this plus sign in the middle here. And then now we divide this term over here now by the bracketed expression, which is x plus 3. So 2x divide 2x bracket 2 bracket x plus 3 divided by bracket x plus 3. So you see that the x plus 3 would cancel out, leaving only 2. And now what we would have here is our final factors. All right, so after we factorize, these would be now the 2 factors from factorizing this expression. Now, just to go back to what I was saying now about the last term being positive. Now, if we were to, all right, let us look at this, the expression now, slightly different from what it is here. So I'm going to write this expression now as, because I want you to get this idea clearly. All right, so suppose instead we have x squared minus 5x. X squared minus 5x plus 6x. All right, can we factorize this quickly? Ms. Trevor, you want to factorize this again for us? Ms. Waysome, are you there? Ms. Waysome, are you there?
Is it 2 and 3?
All right. I'm trying to get somebody else since you would have the first one.
All right.
All right, Ms. Waysome. All right, Ms. Waysome is not responding. Ms. Clark. Ms. Clark, are you there? Guys, somebody respond.
Sir?
Yes, Ms. Clark. You
I
want
was saying, is it -2 times -3?